Earth has a concrete problem. And by that I mean both that the problem is very real, that it is concrete, but I also mean that it is caused by cement. Cement is the ingredient that binds concrete together, and we use it for a lot. And it has a pretty big carbon footprint. According to a 2016 report put out by the European Union, the cement industry is responsible for releasing 4 billion metric tons of carbon dioxide into the atmosphere every year. That is 8% of our global emissions. And that's not just from burning fossil fuels to make it. We could cut some of those emissions by using greener energy to produce cement, but the chemistry of cement itself produces CO2. The good news, though, that chemistry isn't set in stone. In fact, we could totally turn things around and use carbon dioxide to create the building materials we're gonna need anyway. The main type of cement used around the world is known as Portland cement. While its exact chemical proportions can vary, it's pretty easy to make by throwing together some limestone and clay and then heating the daylights out of them. Technically, this process actually makes something called clinker. Cement makers add a few other ingredients like gypsum to create the finished product, but in any case, it's the production of clinker that gives off all that carbon. So the main ingredient in limestone is calcium carbonate. Heating it causes it to break down into calcium oxide and CO2. Then the clay contributes silicon dioxide, and that, plus the calcium oxide from the limestone, creates clinker. Meanwhile, that CO2 from the limestone escapes into the atmosphere. Again, estimates vary, but roughly speaking, a kilogram of clinker production releases around a half a kilogram of CO2. Over the course of a year, that works out to around 1.4 billion metric tons of carbon dioxide from the chemical production of clinker alone. Now, cement does absorb a small amount of CO2 as it ages. In the presence of water, CO2 from the air reacts with calcium oxide to make calcium carbonate again. And that process continues over the lifetime of the product. So our concrete buildings are actually sucking CO2 out of the atmosphere, which is nice to know, but it's not anywhere near enough for the process to break even. A 2016 study found that between 1930 and 2013, cement materials sucked up only about 43% of the carbon given off by cement production over the same period of time. Except that there are factors that prevent concrete from sucking up CO2, like the presence of plaster or too much water, and CO2 doesn't penetrate all the way through the concrete to react with it, so that number might be optimistic. That means cement has a substantial carbon footprint. But there are ways to shrink it, like we could switch to greener sources of energy, as well as make the process of heating the materials more efficient. It's also possible to make cement using less clinker. Other materials can be substituted, and as a bonus, a lot of them are waste products from other industrial processes. They include fly ash, which is a byproduct of burning coal, and slag from iron and steel making. But the supply of those is somewhat uncertain, and besides, we can do even better by rethinking the chemistry of cement altogether. At least that's what a few startups want to do. One of them, called Solidia, claims to have a technique that will allow cement and concrete makers to use carbon as a resource. That means CO2 captured elsewhere could be transformed and incorporated into our building materials. Solidia's cement doesn't start out that different from regular cement. It's made of similar materials. The clay and limestone are still in there. But by backing off the amount of limestone, they came up with a formula that produces less CO2 as it's heated and can be heated to a lower temperature than Portland cement, making the process more carbon efficient. But the real trick is what happens next. To make concrete, you would normally mix Portland cement, water, and gravel and let the whole thing set over a period of weeks. And during that time, the water isn't just drying, it's reacting with components of the cement to bind everything together in a process called curing. But Solidia's process replaces water at this step with carbon dioxide. They basically cast their concrete in a big chamber full of CO2, which reacts with the components in the cement to harden it. They've even recently developed technology to do this in the field rather than just with precast concrete in a factory, which means they need a source of CO2 from somewhere else to finish their concrete. Right now, they have to buy it from industrial sources, but they say they could pair a concrete plant with any factory that produces CO2. CO2. And these chemical reactions go way faster than traditional concrete curing, finishing up in about 24 hours. Solidia is hoping to sell cement makers on the idea that its concrete isn't just greener than the traditional stuff, but it's also faster and more efficient. They're trying to make something that the industry will want. And theirs is only one possible strategy for changing the way we make cement for the benefit of the planet. But good ideas don't always catch on. People advocating for new technologies sometimes lament the valley of death that exists between cool tech innovations and that new tech actually getting adopted. And the cement industry is notoriously resistant to change, which makes sense because if the specs change slightly, you don't want your building to fall over. Any green cement is going to have to convince cement makers that it is commercially viable before they jump in. Still, if we're going to change the building industry, we're going to need to act on all fronts, from switching to alternative fuel sources to totally rethinking the chemistry of cement. This episode of SciShow was supported by Bill Gates, who, through Breakthrough Energy, is working with some of the world's top tech and business leaders to advance clean, reliable, and affordable energy and to scale the technology we need to help the world reach a net zero emissions future.